Hello, boys and girls and Cougar parents. This evening we're going to take a look at scientific notation. I'm going to show you how to take a regular number written in standard form and change that to scientific notation, as well as when you're given a number in scientific notation, what does that mean and how do I change that into a standard form number or just our regular counting numbers. Let's take a look and do some sample problems from tonight's homework.
Let's look at our homework assignment. Numbers 1 and 2, we have two numbers written in standard form and we need to change it to scientific notation. And we know scientific notation is written in the format of a times 10 to the nth power. Okay, a represents our base number and n would represent our exponent. Okay, and the n is actually the most important part maybe of understanding scientific notation, because n is an integer. It can be positive or negative, and that tells the decimal point how many place values to move and which direction. Okay, so whatever number it is, that tells you how many places to move the decimal point, and also tells us whether to move it to the right or left. If it's a positive exponent, you move the decimal point to the right. If it's negative, you're moving it to the left. Okay, so when we look at this number here, I need to change this number. I need to move the decimal point, first of all, to a place where I have a number that is greater than 1 and less than 10. So that would be 5.6. Okay, that's going to be my base number. And then I'm going to multiply it by 10 to some power. Now, in order to get 5.6 to be equal, to go back to 56 10,000ths, I would need to move this decimal point 1, 2, 3 places to the left. So that's going to be a negative exponent. It's going to be negative 3. So it's 5.6 times 10 to the negative third power. If I were to perform this operation on 5.6, it would give me 56 10,000ths. Now, on the other hand, over here, I've got 24,010. Well, I need to use all of my non-zero digits as my base number in my scientific notation, and if there's any zeros trapped in between my non-zeros, I need to include them too. So that forces me to use 2.401. Okay, and I'm multiplying again by 10, and this time though I'm going to move the decimal point. If I want this number to equal that, I need to move the decimal point 1, 2, 3, 4 places to the right. Okay, so this is going to be, since I'm moving it to the right, I'm making the number larger, it'd be to the fourth power. So this is 2.401 times 10 to the fourth power. Okay, this exponent here, it's the guy that's in charge. It tells the decimal point how many place values to move, as well as left or right. If it's positive, you're moving to the right. If it's negative, you're moving to the left. Now we have what I consider to be the easy part of conversions. It's when they give us scientific notation, we simply need to change it to standard form. And basically all we're doing is we're following our directions, we're following our order of operations. And here we've got to take 2.445 times 10 to the third power. Well, remember, our exponent is really the guy in charge. Okay, so our exponent is a positive, so it's, first of all, it says we're moving the decimal point to the right. This exponent is in charge of the decimal, and it's telling us to move it 3 to the right. So I'm going to get 2,445. Okay, and put your decimal point right there. Let's look at number 10. Now, number 10, I've got a negative exponent, so that tells me I'm moving the decimal point to the right, first of all. I had someone mention that, hey, the negative is actually pointing to the direction that our decimal point's going. And I like that. You can use that if you don't understand the concept fully. But -4 means we are doing repeated division. We're moving the decimal point to the left. Anytime you have negative, you move it to the left. So this then is going to go 1, 2, 3, 4. Basically, I'm moving 1 over to get past the 1, and then I have to move 3 more times, and those empty spaces are going to be filled with 0. So I'm going to get 0.000104. Okay, that's 10 400ths times 10 to the negative fourth power. And last but not least, Go to my exponent right away. 3, it's a positive, so I know I'm moving it to the right. My number's getting larger, and I'm moving my exponent 3 places to the right. 1, 2, 3. And that'll give me 5,962. We do have one more. Sorry, I forgot about this one. Okay, here we have 9.165 times 10 to the negative second power. My negative exponent tells me we're moving the exponent to the left, we're making it smaller, and we're going to move it 2 places. So that's going to be 0.9165. Now let's look at 4 or 5 on the back side. Again, we have 2 numbers written in standard form, and we want to write them in scientific notation. So we need to have our base number. Our base number, we need to use our non-zero digits, which would be 3 and 7. And it has to be less than 10 but greater than 1, so that's 3.7. And I'm going to multiply it by a power 10 number. And I need to make 3.7 equal to this ridiculously small number. So I'm going to make 3.7 much smaller. I need to move my decimal point from here to there. Okay, so you got to think of this. This is an equation. This side has to be equal to this side. So what do I have to do to 3.7 to get it to be equal to this? Well, I need to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 zeros. And since I'm going to the left, it's going to be negative 11. So 3.7 times 10 to the 11th power. And if you remember from our exponent, what we're really doing is we're taking 3.7 and we're dividing it by 10 11 times. We're dividing by 10 and then 10 and then 10 and keep on 11 times. So it's repeated division. Okay, here we have kind of the flip side of that. We have 1 billion. Okay, we have 1 billion, and we need to write that in scientific notation. Our base is going to be 1.0. Okay, we've only got one non-zero digit. It's going to be 1.0 times 10, and this time we're moving our decimal point from here all the way to here. Okay, and we're going to have to move it 3, 6, 9. We're going to move it 9 spaces to the right. So it's going to be positive 9. 1 times 10 to the 9th power would be 1 billion.
As always, boys and girls, I hope that was helpful. Please bring your questions to class tomorrow. And remember, tomorrow, Wednesday, we've got a quiz. So be ready. See you tomorrow. Bye-bye.